The solar mass is a standard unit of mass in astronomy that is used to indicate the masses of other stars, as well as clusters, nebulae and galaxies. It is equal to the mass of the Sun, about 2 nonillion kilograms. Ma per mil equals 70301988550000000. Unregistered trademark 1.98855A plus or minus 0.00025A, 1030 kilograms. The above mass is about 700532946000000. Unregistered trademark 332,946 times the mass of the Earth, or 700310480000000. Unregistered trademark 1048 times the mass of Jupiter. Because the Earth follows an elliptical orbit around the Sun, its solar mass can be computed from the equation for the orbital period of a small body orbiting a central mass. Based upon the length of the year, the distance from the Earth to the Sun, and the gravitational constant, the mass of the Sun is given by. The value of the gravitational constant was first derived from measurements that were made by Henry Cavendish in 1798 with a torsion balance. The value he obtained differs by only 1% from the modern value. The diurnal parallax of the Sun was accurately measured during the transits of Venus in 1761 and 1769, yielding a value of 6995436332312998583. Unregistered trademark 9 euro cubed. If we know the value of the diurnal parallax, we can determine the distance to the Sun from the geometry of the Earth. The first person to estimate the mass of the Sun was Isaac Newton. In his work Principia, he estimated that the ratio of the mass of the Earth to the Sun was about 1/28,700. Later he determined that his value was based upon a faulty value for the solar parallax, which he had used to estimate the distance to the Sun. He corrected his estimated ratio to 1/169,282 in the third edition of the Principia. The current value for the solar parallax is smaller still, yielding an estimated mass ratio of 1/332,946. As a unit of measurement, the solar mass came into use before the AU and the gravitational constant were precisely measured. This is because the relative mass of another planet in the solar system or the combined mass of two binary stars can be calculated in units of solar mass directly from the orbital radius and orbital period of the planet or stars using Kepler's third law, provided that orbital radius is measured in astronomical units and orbital period is measured in years. The mass of the Sun has decreased since the time it formed. This has occurred through two processes in nearly equal amounts. First, in the Sun's core hydrogen is converted into helium by nuclear fusion, in particular the pp chain, and this reaction converts some mass into energy in the form of gamma-ray photons. Most of this energy eventually radiates away from the Sun. Second, high-energy protons and electrons in the atmosphere of the Sun are ejected directly into outer space as a solar wind. The original mass of the Sun at the time it reached the main sequence remains uncertain. The early Sun had much higher mass loss rates than at present, so it may have lost anywhere from 1.7% of its natal mass over the course of its main sequence lifetime. The Sun gains a very small mass through the impact of asteroids and comets. However, the Sun already holds 99.86% of the Solar System's total mass, so these impacts cannot offset the mass lost by radiation and ejection. Related units, 1 solar mass. Ma per mil, can be converted to related units, 70072706851000000. Unregistered trademark 27,068,510 milliliters, 70053329460000000. Unregistered trademark 332,946/70031047560000000. Unregistered trademark 1047.56 megajoules. It is also frequently useful in general relativity to express mass in units of length or time. Ma per mil g/c2 a per mil 1.48 kilometers, ma per mil g/c3 a per mil 4.93 I1/4 s. See also. References. Further reading, I.J. Sackman. A.I. Boothroyd. Our Sun be a bright young sun consistent with helioseismology and warm temperatures on ancient Earth and Mars. The Astrophysical Journal 583, 1024 Euro 1039. AR Ziv, Astro PH/02101128. Bibcode 2003 APJ 583.1024 SDOI 10.1086/345408.